A topic on vector. We can calculate the surface area of parallelogram and that of triangle, from the vector point of view. Now let's start with a parallelogram. Let's have a parallelogram in this format. As you can see, this is the side of your parallelogram and this particular side B. So this particular side are written in vector form, and let me say this is the angle theta between them. This side is parallel to this side and this other side is parallel to this other side. Now generally, before we can find the area of this parallelogram in terms of the vector forming the sides of this parallelogram, we can redraw the parallelogram in a scalar form. So this diagram I have here is the scalar form. I'm talking about scalar. Scalar simply means we are only taking the length without the direction. This one is showing direction. So this diagram is vector form. So from the area form, the side is not going to be written as a vector. It's going to be written as ordinary value A, the length of that side. So it's not going to be written as a vector. And this particular side will be written also as a scalar. And this is the angle between them. And then we know generally that the area of parallelogram is base times perpendicular height. But perpendicular height h is not given in this diagram. So we can introduce that height, like putting this one here. Now, finding this h, we can use SOHCAHTOA. Sine theta is opposite over hypotenuse. Sine theta is equal to opposite h all over hypotenuse. The hypotenuse is a. So now to find h, we cross multiply. So our h now is going to be a sine theta. So since we have gotten an expression for h, we can introduce it here. So that means area of that parallelogram is base times a sine theta. We can be written as ab sine theta. That is the area of our parallelogram in terms of scalar. Now we know that a cross b in vector, the angle between vector a and vector b is given as the magnitude of this vector ab sine theta with a unit direction that is perpendicular to these two vectors that is in plane. Now if you look at this that I have here, if I take the magnitude of this cross product, then I can equally take the magnitude of this other side here too, ab sine theta with this unit vector. Since I'm taking magnitude, it's telling me that I'm not interested in the direction, so it's just the magnitude. So this one become ab sine theta. That is magnitude of a cross b is equal to ab sine theta. And you know that this ab sine theta is what I have here as the area of a parallelogram. So that means this a cross b now, instead of me writing it as ab sine theta, I'll just say the area of the same parallelogram. So I've already proved that. So your question can come like you may be given this a, the coordinates of this vector a as a1, a2, a3, and vector b as b1, b2, and b3. So to find the cross product of this now, you just say the determinants. You put the unit vector in the direction of x-axis, y-axis, and z-axis. It is expected that you understand what I'm talking about when you have a space 3D. This direction is the x-axis, this direction is the y-axis, and this direction is the z-axis. For x direction, we indicate with letter I. For y direction, we indicate with letter J. And for z direction, we indicate with letter K. So that's what I'm trying to say here. Then you distribute this vector here for this a cross b. So we have a1, a2, and a3. Then b1, b2, and b3. So whatever you get here is going to be a vector. You find the magnitude of that vector, that will give you the area of this parallelogram. Now Similarly, for us to get the area of a triangle, let's say we have this triangle formed by this side formed by this vector A and vector B with angle theta between them. We know that A cross B is equal to AB sine theta when we are describing cross product of vector cross product. But we want to get the area A of this triangle. Let's move and rewrite it as a scalar without the direction. So the side will just be written as AB and then the angle theta. We know very well that the area of a triangle given two sides and included angle is given as half AB sine theta. Now, if you look at this one and this one now, if I multiply this A by 2, I can write it as 2A is equal to AB sine theta. If you look at this AB sine theta, is what I have here. So this, instead of me writing AB sine theta here, I would rather put this 2A. I will put it here. So I have A cross B. Okay, when we say A cross B, sorry, we have to put a unit vector. So when we take the magnitude of that unit vector, we are going to have AB sine theta. I'm still saying the same thing now. So this AB sine theta is what we have here, which is 2A. So instead of me writing AB sine theta, I'm going to write it as 2A. So if I'm taking the magnitude of this side, I need to take the magnitude of this other side too. Therefore, the magnitude of this cross product A and B is equal to 2A. Therefore, the area of the triangle dividing both sides by 2 is going to be half A cross B is equal to the area of the triangle. So you may be given the unit vector as well as the direction for each of these vector. You may be given the coordinates of each of these vectors. So we just find the cross product using this procedure. And after we have gotten the determinant of the cross product using this procedure, we take the magnitude of whatever we get, then we divide our answer by 2. We are going to have the area of this triangle. So this format that I have here is the vector formula. The format I have here is the scalar formula. The same thing is applicable here. This is the vector formula for the area of parallelogram, and this is the scalar formula for the area of a parallelogram. I believe that you must have learned one or two things concerning what we just did now. Please do not forget to share and like my YouTube. Have a nice day. Bye.